Matatag Curriculum, Science Grade 4, Quarter 1, Lesson 3, Materials and Their Uses. Good day, kids! How are you today? Are you ready for today's lesson? Then, let's start. Our topic is about materials and their uses. This is Teacher Aika, your online teacher. Learning competency. Describe the chemical properties of materials such as they can be burnt, react with other materials, or are degradable or biodegradable. Let's have first the objectives. A. Identify flammable materials and explain their properties. B. Recognize the importance of fire safety precautions and responsible behavior around flammable materials. C. Define chemical reactions and their significance in material interactions. D. Analyze the factors that influence material reactivity and predict outcomes of common reactions. E. Differentiate between degradable and biodegradable materials. F. Evaluate the environmental implications of using degradable and biodegradable materials versus non-degradable materials. Let's talk about matter. Matter has different physical and chemical properties, and these properties determine how it is classified, changed, and used. In the next phase of the lesson, you will learn more about other properties of matter and how to classify these materials according to these properties. Before we start the lesson, let's unlock content area vocabulary, unscramble word game. Let's do this! Rearrange the letters to create a word corresponding to the word given by the teacher. Here is number 1. It is a measure of how quickly a specific material is capable of catching fire and burning. What's the correct answer? It is flammability. Good job! Next, number 2. These are waste products such as packaging materials that can be slowly broken down into simple parts by chemical reactions or physical force. What's the answer? It is degradable. Very good. The third one, waste materials that can be broken down into simpler, non-toxic substances by microorganisms. What's the answer? It's biodegradable. Good job! Let's talk about flammability. Flammability is all about how easily a material can catch fire and burn. Think of it as a measure of how quickly something can go up in flames. If something is highly flammable, it means it can catch fire very easily. If it's not very flammable, it's much harder for it to catch fire. So I have here a video of a paper. Let's watch this. So remember, paper is made from wood pulp and is used for writing, printing, and packaging. Paper is highly flammable and burns quickly when ignited. It usually burns with a bright flame and can be consumed rapidly. Recognizing the flammability of paper is important for fire prevention measures, especially in offices, schools, and home. So let's have some questions about the video. First, did the material or paper catch fire and burn? Why or why not? And here is the possible answer. Yes, the paper caught fire and burned because it is highly flammable. Paper catches fire easily when exposed to heat and oxygen. Number 2. What did you notice about how the material reacted to the flame? Here's the possible answer. The paper caught fire quickly, burned rapidly, and turned to ash. It reacted strongly to the flame due to its high flammability. Third question. How can we tell if a material is flammable or non-flammable? And here is the answer. We can tell if a material is flammable or non-flammable by observing how it reacts to a flame. Flammable materials catch fire easily and burn quickly. Example, paper and wood. While non-flammable materials do not catch fire easily and resist burning. Example, metal and stone. Testing in a controlled and safe environment can help define or determine this. These examples illustrate how different materials exhibit varying levels of flammability and highlight the importance of understanding flammability properties for safety and practical purposes in everyday life. A piece of wood from a tree. Wood is a natural material commonly used in construction and furniture making. Wood is flammable and can easily catch fire when exposed to heat or flame. It burns relatively slowly, producing heat and light. Understanding the flammability of wood is crucial for fire safety in buildings and in forests. A plastic drinking straw used in various products, including packaging, utensils, and toys. Some types of plastic are flammable and can burn when exposed to fire or high temperatures. The flammability of plastic varies depending on its composition and additives. Awareness of the flammability of plastic is essential for fire safety in buildings, transportation, and waste management. Next, we have a metal paper clip. A metal paper clip. Metals are solid materials characterized by their shiny appearance, conductivity, and strength. They include iron, aluminum, copper, and gold. Most metals are non-flammable and do not catch fire under normal conditions. They have high melting points and are not easily oxidized. Recognizing the non-flammability of materials is important for fire-resistant building materials, electrical wiring, and industrial applications. Here's the lesson activity. Divide the class into 4 groups. Each member of every group will decide on the specific role that they will play within their group. Team jobs. Along with each role are color-coded visors with their corresponding meaning. Manager is red, speaker is blue, director is green, and reports coordinator is yellow. So here's the instructions. First, provide each group with a copy of the activity titled Flame Test. Remind the teammates of their roles. Second, students perform the activity as directed and answer the questions provided in the worksheet. Third, ask the students to present their output in class. Let's have the guide questions. First, how did you notice about how each material burned? Second, did all materials burn in the same way? Third, why do you think some materials burned while others did not? And the last one, why is it important to be cautious around flammable materials? Today, we learned how paper, a flammable material, catches fire easily and burns quickly. This helps us understand the importance of fire safety. Remember, it's crucial to handle all materials responsibly and never play with fire. Always seek adult supervision when dealing with anything that can be dangerous. Safety first. This time, let's have another topic about how materials react with other materials. Materials can react with each other when they come into contact. This reaction can cause changes in the materials involved. So let's watch this video.
Here's a really simple science experiment you can do using nothing but vinegar and baking soda. It's baking soda, it's vinegar. When you mix them together, you get a chemical reaction. Watch. By the way, it's a chemical reaction because it creates a new substance. Whenever you mix the two, it creates carbon dioxide, a gas. That's one way you can make the typical science experiment of the volcano. Take baking soda, pour in the vinegar, and it makes like lava, fake lava. But here's some other cool things you can do. Take a water bottle, pour in some vinegar, take a balloon, and try to fill it up with some baking soda. It's going to be kind of hard unless you have a funnel. You got to stretch out the balloon. This is called the self-inflating balloon. I have baking soda in here. I have vinegar in here. Look at all that carbon dioxide, a gas. Another fun thing to do, take these film canisters. You can get them on Amazon. I'll leave a link below where you can buy them, real cheap. And you can create these little miniature explosions. Basically, you're gonna do baking soda in here, pour the vinegar in real quick, cap it. And what happens is the gas is gonna be released, pressures are gonna build up, and it's gonna explode off the top. Watch. This one's a little harder because you gotta be really quick. It gets a little messy too. Oh, look who joined us. Hey guys. Wah wah wee wah. Here we go. It didn't work. Like I said, this one's gonna be really tough. I have an idea. Put baking soda on the cap. Put vinegar in the bottle. God! Dang it. That's messy. But that was fun, so let me try it again. Put baking soda in the cap. Put vinegar in the bottle. Thanks for watching. Try it. It's fun.
Vinegar is a weak acid commonly used in cooking and cleaning, while baking soda is a base commonly used in baking and household cleaning. When vinegar or acetic acid is mixed with baking soda or sodium bicarbonate, a chemical reaction occurs, producing carbon dioxide gas, water, and sodium acetate. This reaction is commonly used to create a foaming eruption resembling a volcano. Understanding the reaction between vinegar and baking soda demonstrate the concept of acid-base reactions and is commonly used in educational demonstrations and science experiments. Let's have these examples. Rusting of iron. Iron is a metal commonly used in construction and manufacturing. When iron comes into contact with oxygen and moisture in the air, it undergoes a chemical reaction known as oxidation. This results in the formation of iron oxide, also known as rust. Understanding the reaction between iron and oxygen is crucial for preventing corrosion in metal structures and equipment. Protective coatings and proper maintenance can help mitigate rusting. Foam production in hydrogen peroxide and yeast experiment. Hydrogen peroxide is a chemical compound often used as disinfectant, while yeast is a microorganism used in baking and brewing. When hydrogen peroxide is mixed with yeast, the enzyme catalase in yeast catalyzes hydrogen peroxide's decomposition into water and oxygen gas. This reaction produces foam as a result of the release of oxygen gas bubbles. Understanding the reaction between hydrogen peroxide and yeast demonstrates the role of enzymes in catalyzing chemical reactions and is commonly used in educational experiments. Aluminum foil reacting with air. Aluminum is a lightweight metal commonly used in packaging, construction, and transportation. When aluminum comes into contact with oxygen in the air, it forms a thin layer of aluminum oxide on its surface. This layer acts as a protective barrier, preventing further oxidation. Understanding the reaction between aluminum and oxygen helps prevent corrosion and maintain the integrity of aluminum-based products, such as aluminum foil and aluminum alloys used in aircraft construction. Weathering of limestone by acid rain. Limestone is a sedimentary rock composed primarily of calcium carbonate. When limestone is exposed to acid rain, which contains sulfuric and nitric acids, it undergoes a chemical reaction called acid erosion. The acid reacts with the calcium carbonate in limestone, dissolving it and causing the rock to deteriorate over time. Understanding the reaction between acid rain and limestone highlights the environmental impact of air pollution on natural rock formations, historical monuments, and building materials. The reaction between acid rains and limestone highlights the environmental impact of air pollution on natural landscapes and architectural heritage. It contributes to the degradation of limestone buildings, statues, and monuments such as the limestone facades of historical buildings and sculptures in urban environments. Next, we have tarnishing of silver jewelry. When silver comes into contact with sulfur compounds present in the air, water, or certain materials, it undergoes a chemical reaction called tarnishing. Understanding the reaction between silver and sulfur compounds helps explain the tarnishing process and guides the proper care and maintenance of the silver objects and jewelry. These examples illustrate how materials can interact and undergo chemical reactions with other substances, leading to the information of new products and properties. These examples demonstrate how chemical reactions between materials occur in real-life situations, affecting industries, environments, and everyday objects. Understanding these reactions is essential for various practical applications, ranging from corrosion prevention to the environmental conservation and product maintenance. Let's have a lesson activity. Divide the class into 5 groups. Each member of every group will decide on the specific role that they will play within their group. Team jobs. Along with each role are color-coded visors with their corresponding meanings. Manager is red, speaker is blue, director is green, reports coordinator is yellow. Next, ask the students to go over worksheet number 2 titled Chemical Reactions Exploration. Remind the teammates of their role, and students need to perform the activity as directed and answer the questions provided in the worksheet. Allow the students to present their output to the class. And here are the guide questions. First, what happened when you fixed certain materials? Second, did you observe any bubbles, color changes, or other reactions? Third, how did the materials behave differently when combined? And fourth, can you identify any patterns or similarities in the reactions you observed? And last, how might these reactions be useful in everyday life or science? Let's have another topic about degradable or biodegradable. Let's start. Degradable materials can break down into smaller pieces over time by chemical reactions or physical force, while biodegradable materials can be broken down by living organisms into simpler substances. Let's take a look at this video. And here are the guide questions. First, describe the appearance of the apple core. Second, why is the apple core considered biodegradable? Third, how do living organisms such as bacteria and fungi contribute to the biodegradation of such material. Fourth, how does composting apple cores contribute to the sustainable waste management? And fifth, what environmental benefits result from returning nutrients to the soil through composting? The apple core is biodegradable, meaning it can be broken down by living organisms, such as bacteria and fungi, into simple substances over time. When discarded in a natural environment, microbes in the soil break down the apple core through the process of decomposition. The organic matter in the apple core provides nutrients for soil organisms, contributing to soil health and fertility. Biodegradable materials like apple cores can be composted, returning nutrients to the soil and reducing waste sent to landfills. These are the examples for degradable. First, plastic straw. A plastic straw is degradable, meaning it breaks into smaller pieces over time due to sunlight, heat, and moisture, but it doesn't biodegrade. These small pieces of microplastics can persist in the environment and harm wildlife. This highlights the need to reduce single-use plastics. Next is polystyrene foam or styrofoam. Polystyrene foam used in packaging and food containers is degradable, breaking into smaller pieces over time due to sunlight, heat, and mechanical stress. This degradation results in microplastics that persist in the environment and can harm wildlife. This underscores the need to reduce single-use plastics to address plastic pollution. Next is nylon fishing line. Nylon fishing line is degradable and breaks into smaller pieces over time due to sunlight and mechanical stress. These fragments can persist in the environment, posing risk to aquatic life through entanglement and ingestion. This highlights the need for proper disposal and eco-friendly alternatives to minimize environmental impact. Now, let's have biodegradable examples. First is paper towel. A paper towel is biodegradable and breaks down into simpler organic compounds through microbial decomposition. When composted, microorganisms like bacteria and fungi convert it into humus, enriching soil and supporting sustainable waste management. This process helps divert organic waste from landfills and improves soil fertility. The second one is banana peel. A banana peel is biodegradable, meaning microorganisms break it down into simpler compounds over time. In nature or compost, microbes decompose the peel, enriching the soil with nutrients and improving soil health. Composting banana peels helps reduce landfill waste and returns valuable nutrients to the soil. The third one is cotton fabric. Cotton fabric is biodegradable and breaks down into simpler organic compounds through microbial degradation. When composted or discarded in nature, microbes decompose the fabric, enriching the soil with nutrients and supporting soil health. This process minimizes the environmental impact and promotes sustainable waste management. Let's have a lesson activity. Provide each group with a copy of the activity titled Exploring Degradable and Biodegradable Materials. Again, remind the teammates of their role. Ask the students to perform the activity as directed and answer the questions provided in the worksheet. Ask the students to present their output to the class. Let's talk about learners' takeaway. Outline the concept map about what they have learned in the lesson and utilize the given concept map below. Here's the concept map. Chemical properties of materials. Under it, we have flammability, reactivity with other materials, and degradable and biodegradable. And here are the answers. Chemical properties of materials is actually divided into three. Flammability, reactivity with other materials, and degradability and biodegradability. So let's have first the flammability. It means how easily something catches fire. Example, paper, gasoline, metal, and glass. And reactivity with other materials means refers to how substances interact. Examples, reactive, baking soda plus vinegar, non-reactive, sand and glass. Degradable and biodegradable is divided into two parts, degradable and biodegradable. Let's have first the degradable. Degradable means breaks down over time. Examples, paper and some plastics. Biodegradable means broken down by nature microbes. Example, food, scraps, or leaves. Remember the following terms for this lesson. First, flammability or burnability. Some materials can catch fire and burn when exposed to heat or flame. For example, wood, paper, and certain types of plastics can burn. This burning process is a chemical reaction where the material combines with oxygen in the air to produce heat and light. It's important to be cautious around flammable materials and to never play with fire. Next, we have reactivity with other materials. Materials can react with each other when they come into contact. This reaction can cause changes in the materials involved. For instance, when iron or a metal reacts with oxygen and moisture in the air, it forms rust. Similarly, when vinegar or an acid is mixed with a baking soda as a base, it produces bubbles of carbon dioxide gas. Understanding these reactions helps us predict how materials will behave when combined. Next, we have degradability and biodegradability. Materials can break down or decompose over time due to various factors such as exposure to sunlight, air, water, or microorganisms like bacteria or fungi. Degradable materials eventually break down into smaller pieces, while living organisms can break down biodegradable materials into simpler substances. For example, food scraps, paper, and certain types of plastics are biodegradable, meaning they can break or they can be broken down naturally by bacteria and other organisms in the environment. These properties help us understand and how different materials interact with their surroundings and with each other. which is important for various everyday activities and environmental considerations. Let's have the formative assessment. Directions: read each question carefully. Identify the letter of the correct answer. Number 1. Which of the following best describes flammability? A. The ability of a material dissolve in water. B. The ease with which a material can catch fire and burn. C. The tendency of a material to react with oxygen in the air. And D. The ability of a material to conduct electricity. The correct answer is letter B. The ease with which a material can catch fire and burn. Next, number 2. What is an example of a flammable material? A. Glass, B. Material, C. Paper, or D. Rock? The correct answer is letter C. Paper. Number 3. When iron reacts with oxygen and moisture in the air, what does it form? A. Aluminum oxide, B. Rust, C. Carbon dioxide, or D. Hydrogen gas? The correct answer is letter B. Rust. Number 4. Which of the following materials is biodegradable? A. Plastic drinking straw, B. Nylon fishing line, C. Banana peel, or D. Styrofoam packaging? The correct answer is letter C. Nylon fishing line. Number 5. What happens to a banana peel when it is discarded in a natural environment? A. It remains unchanged indefinitely. B. It decomposes into simpler organic compounds. C. It reacts with other materials to form new substances. Or D. It breaks down into smaller pieces over time. The correct answer is letter B. It decomposes into simpler organic compounds. Number 6. Sarah wants to dispose of her plastic water bottle. Plastic is harmful to the environment, so she wants to choose a more eco-friendly option. Which of the following materials should Sarah choose if she wants a biodegradable option? A. Plastic water bottle, B. Glass bottle, C. Aluminum can, or D. Biodegradable paper cup? The correct answer is letter D. Biodegradable paper cup. Number 7. Tom is conducting an experiment in his science class. He wants to observe how different materials react with vinegar. Which of the following materials is most likely to produce bubbles when mixed with vinegar? A. Metal paper clip, B. Plastic drinking straw, C. Glass marble, or D. Cotton ball? The correct answer is letter D. Cotton ball. Number 8. Emily is decorating her room and wants to hang up some pictures using metal nails. She is worried about the nails rusting over time. What can Emily do to prevent the nails from rusting? A. Paint the nails with a waterproof sealant. B. Keep the room temperature low to slow down the rusting process. C. Use plastic nails instead of metal nails. Or D. Nothing, as rusting is inevitable for metal nails. The correct answer is letter D. Nothing, as rusting is inevitable for metal nails. Number 9. David is helping his mom in the kitchen. She accidentally spilled some lemon juice on the marble countertop. What is likely to happen to the marble over time? A. The marble will remain unchanged. B. The marble will dissolve and disappear. C. The marble will develop stains and discoloration. Or D. The marble will react with the lemon to form a new substance. The correct answer is letter C. The marble will develop stains and discoloration. Number 10, Anna is packing her lunch for school. She wants to use a material for her sandwich wrapper that will break down easily when discarded. Which of the following materials should Anna choose? A. Plastic cling film. B. Aluminum foil. C. Biodegradable wax paper. Or D. Styrofoam container. The correct answer is letter C. Biodegradable wax paper. And that wraps up today's lesson. If you enjoyed this video and want to see more content like this, don't forget to hit the subscribe button and ring the bell so you never miss an update. Thanks for tuning in and I'll see you in the next video. Thank you!